Can you see my screen? Okay, that is great. Let us start. So I'm going to cover these topics, which is basically post-midterm topics of the MOL, all of the pathways and whatnot. Okay, so this is the metabolism, and let's start with brief concepts of and definitions. Okay, so what are the metabolic processes of the cells? You can type or you can open your mic. I don't mind. Let's make it an interactive session. Okay, so what are the metabolic processes? The answer is there. Okay. Yes, anabolic and yes, exactly. So what are anabolic reactions? Building. Okay, that is correct. And what is catabolic reactions? Okay, catabolic is breakdown. So anabolic reactions, they require energy. To build something, you need energy for it. And catabolic reactions, they produce energy, okay? Okay, what is fuel oxidation? Okay, no answer? Okay, I'm gonna wait for 5 more seconds. Let's see who gets that. It's basically so easy. Okay, so fuel oxidation is basically using oxygen and releasing carbon dioxide. That's fuel oxidation. I just found it in your slides. I had to add it, but it's that. Okay, so what is RBC undergoing glycolysis? RBCs can only undergo glycolysis because RBCs lack mitochondria. That's correct. Oh my God, sorry. Metabolic pathways are regulated by. They are regulated by the list of things that you need to memorize in ATP. Okay, but they're regulated by what? We need something to produce ATP. Hormonal, allosteric. Okay, enzymes. Okay, enzymes. We need enzymes to regulate metabolic pathways. Okay, what is the rate limiting step? The slowest step. Okay, I need three keywords. Three keywords for the rate step. It's highly regulated, it is the committed step, and it's the irreversible step. Yes, good job. Okay, so three things that you need to know in rate limiting step. It's highly regulated by enzymes and intermediates. It's committed step, that if we need to commit to this step to undergo our pathway, and it's irreversible, that we cannot go back. Okay, and list some functions of ATP. This is basically general. You can type in the chat. Okay, ion pumps. Good job. Someone else? Maintaining protein gradient. Yeah, exactly. Everything. And we need it for motility, for growth, for repair, for ion pumps, endocytosis, exocytosis. ATP is, the famous word. It's the energy currency of our cells. Okay, let's start with our questions. I'm sorry that you saw the answer, but let's discuss it nonetheless. What is the enzyme that is used to catalyze this pathway to form product 6? Okay, C. Why C? That is correct. Yes, YC. Can anyone explain? If you can type or just mute your mic, unmute your mic. I don't mind. Okay. Why not C? Why not D, for example? Why not E? I thought it's E in the beginning, but why not E? Okay. Do you have answers? Okay, let me explain. So, for example, if we inhibited enzyme A, we will not have product 2. Okay, we will not have any of the pathways anyways. If we blocked product or enzyme B, we will not have 3. So enzyme B is committed to this pathway. And if we committed C, we will commit to this pathway. It's not E, because we can go back to 5. We can go back to 4, okay? But we cannot go back from 4 to 2 because it's committed. If we go back to 2, it will go to 3. Do you get the point? So C is the committed step. And this question was in the slides. So focus on any questions that came on the slides. I only found this, so I added it. Okay, let's have this. It's a tongue twister. Which of the following is not a catabolic reaction? Not a catabolic reaction. So think about the definition of catabolic or catabolism and look at the options and rule out the correct ones. Okay. Is it D? Yes, it's D. Good job. It is D. Why is it D? What is glycogenolysis? It's a tongue twister, I swear. Okay, what's glycogenolysis? It's the breakdown of glycogen. What is glycolysis? Glycolysis is a breakdown of glucose. Gluconeogenesis, neo, it's the breakdown of new things, so new things, fats and proteins to make glucose. Notice that I said breakdown. So this is the keyword. Breakdown is for catabolic reaction. Glycogenesis, however, is the production of glycogen. Okay, that's pretty easy. We are done from our first objective or our first lecture. This is just a table to memorize or summarize the difference between anabolism and catabolism. And here are the pathways. And ignore the things that you didn't take, like chemosynthesis. You didn't take that, but because this is a picture from the internet. Okay, so can you guess what are we going to solve next? I will break the 6 into 3. I will give you 4, and later I will take the 2. I will change the NAD into a reduced version, and that can happen everywhere, and I'm glycolysis, okay? So this is basically a shortened version or a mnemonic for glycolysis. Breaking the 6 into 3 is what? Can someone guess? Carbon molecules, okay. Okay, all of them are carbon, but 6 into 3 specifically, I want something. Pyruvate into 2, no. Okay, we're talking about glycolysis. Okay, so 6, it's glucose. Glucose has 6 carbons into 3, which is pyruvate. So you were close, Haja. Good job. And $4, I'll later take 2. Remember when I said that the ATP is the currency, so dollars here is the currency. You will give 4, I will give you 4, but later take 2, meaning that the net gain of ATP molecules in glycolysis is 2 ATP molecules. Okay, you know that we produce 4 ATPs, but then we later use them in the pathway of the committed step, the first step. Okay. Okay. So here are the main enzymes or the steps in the glycolysis. First, you have hexokinase, or what enzyme? What is the, the parallel enzyme of hexokinase?
Glucokinase.
Yes, good job. Bravo, Aliki. Where is glucokinase?
Liver and beta
Yes,
cells in
exactly.
pancreas.
Yes, good job. So glucokinase is in the liver and in the pancreas, hexokinase in all of the tissues. Keep this in mind, okay? Let's have this idea at the back of your mind. And then we have the PFK, which is the regulatory step of glycolysis, which will convert the glucose into fructose, or like the glucose bisphosphate into fructose bisphosphate. And then we have ATP production by substrate level phosphorylation. This is remember when I told you 4 into 2, you produce 4 here, and then you use the 2 here, because these 2 steps require ATP, okay? The fourth step is enolase, which is converting glycerate into PEP, and then the last step is pyruvate kinase, where we reach our final destination to make our pyruvate. Okay, this is the summary of it: 6 carbons into 3. Okay, so 6 into 3, glucose into pyruvate, and 2 molecules of pyruvate, because basically the half of the 6 is the 3. Good job. Here you can see that we produced 2 ATP molecules, so the net gain is the so of the steps will record then you used to 2. Okay, I hope you get that. Okay, let's solve. I will give you time to read the question and solve it. Okay. Okay. Do you have any guesses for the answer? Okay, so is it C? Yes, it's C. Good job. Okay, so we have an episode of hypoglycemia, but then we measured the hormones levels and we found that insulin and glucagon are normal and respond to the feeding and the fasting cycles. Okay, so we know that our patient doesn't have a problem with eating and not a problem with the hormones and not a problem with the lifestyle because everything suggests that he is normal, but he is still hypoglycemic. Why? What is the reason? And I told you guys, remember when I showed you this like summary slide? Hexokinase and glucokinase, right? So why is the answer? Can someone explain? If not, it's okay. I'll explain anyways. Okay. No one was willing to volunteer. It's fine. So when we think about a problem regarding metabolism, we directly think about enzyme problem. Okay, and I told you that hexokinase is the enzyme found in all tissues, and glucokinase is found in the liver, mainly in the liver, also in the pancreas, but also mainly in the liver. And physiologically, we have the affinity constant, which is the Km, or the substrate constant. Km in hexokinase is lower than glucokinase. I want to show you this graph. Okay, so when we talk about lower, that means it's more affinity. Okay, so hexokinase normally it has high affinity to. Sorry, guys. Hexokinase normally have high affinity to glucose, and glucokinase has high affinity to glucose. Okay. Oh my God. Okay, look at this graph. I'm sorry for the confusion. Glucokinase, it has low affinity to glucose because it has higher Km. Okay, look here, the Km is high. And hexokinase, it has high affinity because the Km is low. So basically, it's a reverse or inverse relationship. If Km is high, then the affinity is low. And if Km is low, then the affinity is high. Okay, in the case of our patient, the Km of glucokinase was basically the same or like equal to the Km of hexokinase. Okay, so the affinity is the same. The liver now and the pancreas is taking all the glucose that we are eating and it's not reaching the tissues, and that is why the person is having hypoglycemia. Okay, so this is and normally the liver it's a generous organ. Okay, the liver it's a generous organ, so it will have the glucokinase, which has a low affinity to glucose, so that when the glucose reaches other tissues, it's available. But now in our patient, the glucokinase in the liver is having equal affinity with the hexokinase. Do you get the idea? So, did you get it? Can someone answer? I will explain again. Okay, it's clear. Someone said glucokinase is not regulated by insulin. That is correct, but in our question, he said that circulating insulin and glucagon are normal. So it's not a problem with the hormone levels. Okay, so it's basically a problem with the enzyme structure and the Km and affinity and whatnot. Okay, so have this graph. Okay, okay. Next question. Okay. B, yes, you are correct. It is B. Okay, why is it B though? Why is it B? Okay, think about regulation. Think about this guy. Okay. Okay, let's explain. So they mentioned in the question citrate, and they mentioned it here for a reason. He needed, citrate is important here because if you look at this slide, I drew that. This is the pathway of glucose, and this is phosphofructokinase or PFK1, which is regulated. It's the regulatory step of glycolysis as well. Okay, if you give citrate or ATP, it will negatively impact or negatively inhibit the PFK1. Okay, so when they mention citrate in the question, they want you to think about negative inhibition or basically just regulation of the regulatory step of glycolysis. So you know that the regulatory step of glycolysis is the PFK1, and it is regulated negatively or it's inhibited by citrate and ATP, and it is stimulated or activated by AMP and fructose bisphosphate 2,6 fructose 2,6 bisphosphate. Okay, so did you get it? So have this image in front of your mind and draw the pathway. Okay, one tip in pathways or MOL in general is to draw the pathways and draw what regulates it and what inhibits it next to the enzyme. So this is the regulatory step, this is what inhibits it, and this is what stimulates it. Great. Is that clear? Everyone, did you get why it's B? Okay, that's great. Okay, next question. It's related to what we just discussed and explained. Okay. Okay. Can someone answer or should we just reveal? Okay. Okay, so you discovered that the addition of the compound results in an increased rate of ATP, which is a good thing. Glycolysis is working. A lot of ATP is produced. So producing glucose while simultaneously reducing the glucose output from this culture media, basically using the glucose in the culture media. And experimental compound showing the mimicking of which of the following enzymes. So think about something which stimulates the rate of glycolysis or activates an enzyme which increases the rate of glycolysis. Did you get the answer? B. That is correct. Good job. Again, to this diagram, I want you to zoom in. I had to zoom in, but okay, sorry about that. We said that PFK1 is stimulated by rising levels of AMP and fructose 2,6 bisphosphate. Okay, what is this 2,6 bisphosphate? It's basically fructose 6 phosphate, but instead of being converted into 1,6, it's being a 2,6. Okay, so fructose 6 phosphate in the pathway of glycolysis will become a 1,6 by PFK1. Okay, so the 6 will be 1,6 by the 1 by PFK1. The same enzyme, but PFK2 will convert the fructose 6 phosphate into fructose 2,6 bisphosphate. So PFK2 will convert the 2,6. And apparently, they found out that this 2,6 will stimulate the PFK1. So I know it's a tongue twister. I know it's like a little bit confusing, but you will get it. So the 6 should be converted into the 1,6. Okay, so fructose 6 phosphate should be converted to 1,6 by this regulating enzyme. This enzyme will be stimulated by the 2,6. Okay, so think about them as brothers or like sisters, whatever. The 2,6 will will pump up the 1,6 to be produced more. Did you get it, guys? So any question which tells you rate of something ATP or gives you an intermediate, like in that question when we mentioned citrate, think about regulatory steps of any pathway in general, not just glycolysis. And okay, is that clear, everyone? Okay, great. Okay, now this enzyme, sorry, this question. guys. Here. Take your time answering them. Okay. Do we have answers? If someone wants to unmute their mic and explain or answer, I don't even mind at all. Please do that. C. That is correct. Good job. Why is it C? Why is it C? Okay, the why, or why is it C, is because they said in the first line, it's anaerobic glycolysis, anaerobic. Okay, what is the pathway of anaerobic glycolysis? It's this one. We made pyruvate. Okay, it's done. And then instead of going into the TCA and the oxidative phosphorylation, and from the name that uses oxygen, they said anaerobic. So we will go into lactate. You know, basically when you exercise or when you run, you are out of breath, and next day you are sore. Why? From the lactic acid. This is a known thing. Why from the lactic acid? Because we went through this pathway and not the others. Okay. Ignore this. You don't have this, but just focus on this pathway. Okay, you made pyruvate and you made lactate, and they said it's anaerobic glycolysis. Okay, and the second thing is that NAD plus is required for glyceraldehyde 3-phosphate. It's basically here as well. You use the NADH that you made in the glycolysis pathway and you oxidize it because this is hydrogen and you lost the hydrogen. Losing hydrogen is oxidation, right? So you oxidize the NAD and it's now NAD plus. This NAD plus will go all the way back to glyceraldehyde 3-phosphate to undergo glycolysis again. So it's a cycle, right? Because you need energy. If you are out of breath while exercising and you cannot undergo oxidative phosphorylation, then you will use this pathway, and that's why it's anaerobic glycolysis. And what supplies this pathway to continue is this NAD plus and NADH. Okay, you make NADH and you use it here, and NAD plus will go back to make another NADH, and so on and so forth. Okay, so it's a cycle. Did you get it, guys? Is that clear? Okay, great. Okay, the last question in this glycolysis lecture. Okay, the Warburg effect in cancer is to ferment glucose into lactate to support mitochondrial oxidative phosphorylation. Okay, what is the enzyme responsible for this? Do we have any volunteers, answers? Okay. B. Let's see. No, it's not. It's E. Why? Okay, let me explain. Nice try though. Good job. This is the keyword here. Cancer cells tend to ferment glucose into lactate, even in the presence of sufficient oxygen to support mitochondrial oxidative phosphorylation. Okay, so we want pyruvate at the end of the day. We need pyruvate. The cancer cells, basically, it's a concept. You don't need to worry about it now, but the cancer cells will always choose glycolysis over any of the pathways present. It will always choose glycolysis. When you always choose glycolysis, you will not have Krebs, you will not have oxidative phosphorylation, you will not have anything. So what is the fuel that will continue this, that will, what is the fuel in this cell? It's the glycolysis. And what supplies the glycolysis cycle to continue? It's this lactate dehydrogenase reaction and making lactate, okay? Because they said in the question, it ferments glucose into lactate. But in order to ferment glucose into lactate, what do you need? You need pyruvate. How will this pyruvate come? What is the step that will synthesize pyruvate directly? The last step of glycolysis, it's pyruvate kinase, okay? Sorry, let me go back a lot. Look here. This is the last step of glycolysis, pyruvate kinase, which basically converts PEP, the phosphoenol pyruvate, into pyruvate, okay? This is the last step. So if you have glucose in the first step and you need the last step, which is pyruvate, you need this enzyme. This is the last step, okay? That's why the question was talking about here. You are fermenting glucose into lactate, and you need pyruvate. Which enzyme synthesizes pyruvate directly? It's pyruvate kinase. Did you get it, guys? Okay, great. If someone wants me to repeat, I don't mind at all, okay? So I'm just taking your word for it, okay? Munib. Okay, let's continue. This is the last slide in glycolysis, and we'll go to the next lecture, but focus on clinicals and regulatory hormones and everything. So this is the regulation that I told you about, the PFK1 and the PFK2 regulations. What inhibits it? I told you what inhibits PFK1 was, can someone tell me? Okay.
ATP.
ATP, good. And something else?
Citrate.
Citrate, good job. And what stimulates it or what activates it?
AMP and fructose 6-phosphate.
Your voice is lagging. But it's AMP and fructose 2,6-bisphosphate. Okay, and hormonal regulation of glycolysis, which is insulin and glucagon, and enolase inhibition by fluoride. In the slides, if you used fluorides for anti-caries and basically for teeth hygiene and oral hygiene, it will over time inhibit the enolase enzyme. Okay, and pyruvate kinase deficiency. Unfortunately, it does give you Heinz varese and hemolytic anemia. And why is that? Because build up of, I will tell you why. I told you in the beginning that RBCs are not using any of the other pathways. It only uses glycolysis because it lacks a mitochondria. Okay, if you have pyruvate kinase deficiency, you are not making pyruvate, yes? Okay, that means that the cell will die and it will agglutinate, the hemoglobin itself will agglutinate on each other, and it will form what we know as Heinz bodies and hemolytic anemia, because the red blood cells will basically, it will not have energy, it will burst and hemolysis will occur. Okay, did you get it? And lactic acidosis. Can you tell me why not then? It was mentioned in your slides, guys. Okay, so why not lactic acidosis? Let's go here. If you have accumulation of lactate, and lactate, anything which ends with ATE, it's an acid, okay? And lactate and a buildup of acid in your body is basically acidosis, yes? So you have lactic acidosis, and obviously you guys are well more informed about this than me because you are taking the renal block, right? Good job. Okay, now we are going into TCA Krebs cycle and or the citric acid cycle. Okay, let's start. This is a mnemonic for the citric acid cycle. Can I add some fantastic memes on? It's C for citrate, I for isocitrate, A for alpha ketoglutarate, some, or like the S here, it's for succinyl-CoA and succinate, or succinate and succinyl-CoA, if we are talking with the order here. And F is fumarate, M is malate, and O is oxaloacetate. It will go on and go on and go on. Okay, so you have oxaloacetate. It will bind with acetyl-CoA and give us citrate, and citrate will give us isocitrate. and isocitrate will give us alpha ketoglutarate, and so on, and the cycle continues. And the main aim of this cycle is to give us NADHs and FADH, as well as ATP, but this is not the main thing, because we want these what you call them, coenzymes and cofactors, to go into the electron transport chain. Okay, so let's start with the questions. Okay, take your time answering and let me know what you think. Okay, C. Yeah, it's correct. It's C. Okay, tell me why it's C. It's a clinical. It's basically just recall. What does arsenic do? Inhibit lipoic acid. Good job, bravo. Okay, so this is basically one of the clinicals that you have in this lecture, that you have the complex pyruvate dehydrogenase, which needs lipoic acid to function, and arsenate, which is a poison, will inhibit the lipoic acid, which will interfere with this enzyme's activity. Okay, did you get it? Everyone? Okay, good. Let's do this question. Okay, which of the following vitamins is needed for the synthesis of a cofactor required for the conversion of succinate to fumarate? You just took the vitamins lecture, I hope, and you finished it again, I hope, but let's see. D, riboflavin, good job. Fumarate, riboflavin, it's which vitamin though? What's the letter? B what? Good job, everyone. B2, yes, good job, bravo. Okay, the
I have a question.
Yeah, sure, go ahead.
Are the questions like they're not in order like of the lectures, right? Like they're just random, right?
No, they are in the order with the lectures, but it's riboflavin. You have a clinical case with it, so that's why I added it in the TCA. But don't worry, you have good questions in the TCA.
Because like the vitamins lecture was like at the end.
Yeah, it is at the end. I am ordering the lectures. Basically, we are here in TCA, and then at the end we will have another vitamins lecture. But
Okay.
but see here, it's succinate to fumarate, and these are intermediates in the TCA, right?
Yes. Okay.
Okay. So, for example, you could have had chosen niacin, which makes NADH. NADH is also a vitamin, but it's also not the cofactor or the coenzyme in this step, right? This step specifically is for riboflavin, which makes us FADH. Okay, that's why I added it here. It's linking, the lectures. Okay. Okay, let's move on. This is the next question. In the TCA cycle, GTP is produced via a process referred to as substrate level phosphorylation. And what is the enzyme that converts this into this? D. We have a lot of these. Good job, guys. So it's basically just remembering the cycle and knowing which cofactor is in which substrate. Okay, good job. Anaplerotic reactions are those that result in replenishing the intermediates of TCA. Which of the following enzymes catalyzes an anaplerotic reaction? Okay.
C.
C, good job. Okay. Can you explain, if you volunteered, please go ahead and explain. What is anaplerotic reaction and why did you choose C?
I think anaplerotic means like it leads to another pathway. In this case, it leads to
Yes.
gluconeogenesis.
Okay. Yeah.
From
Yes.
pyruvate to oxaloacetate.
Yes. Good job. Good job. You got it. Okay. So think about anaplerotic reactions as suppliers for ingredients you need in recipes, and recipes are other pathways. So good job. And this is the enzyme that requires it. And pyruvate carboxylase, as you correctly mentioned, it converts. What? Tell me. into oxaloacetate. Yeah, pyruvate into oxaloacetate. Okay, good job, guys. These are the clinicals in TCA. This is the first question that I said that arsenate will inhibit the lipoic acid in the pyruvate dehydrogenase complex. And the PDH deficiency will lead to something called congenital lactic acidosis. And why is that? You cannot, you don't have the enzyme that will lead you into the TCA and the oxidative phosphorylation. So you are basically judged into going into glycolysis. You don't have any other option. You will do only glycolysis, and you will do anaerobic glycolysis leading to a lot of lactate, and this will lead to lactic acidosis. So this is basically the pathophysiology behind it. Beriberi or vitamin B1 deficiency is for thiamine, because also the PDH is a complex and it needs lipoic acid and thiamine and something else. Can someone tell me? It needs three things. Okay, no answers. Okay, pyruvate dehydrogenase requires lipoic acid, thiamine, and biotin. Okay. Okay, vitamin B2 deficiency is FAD, and Pligra is vitamin B3, which is NAD, and terms that you need to know is anaplerotic reactions and amphibolic reactions. Okay, okay. Now, do you guys want a break for Maghrib, and we can come back, or we can continue and then take a break? What do you think? This would be only like a max, yeah. Okay, sure. A break, and I'll stop sharing the screen. It's 40 now. Let's come back at 50, and yeah, let's see you. Okay. So can everyone see me? Sorry, see my screen? It is shared, thank goodness. Okay. Okay, guys. So two things before we start. About pyruvate kinase deficiency, I'm sorry, you are right, whoever corrected me, and thank you for pointing that out, because I went and checked the lectures, and pyruvate kinase deficiency will give you hemolytic anemia, but no Heinz bodies. Okay, so that was a mistake on my part. So thank you so much for pointing that out, and without further ado, let's continue. Okay, so ETC reactions of electrons. Yeah, ETC is electron transport chain, and we are basically just moving electrons around. So these are the main steps, as we said in after every lecture or before we start every lecture. This is just a broad review, and let's see. This is complex 1. These numbers are showing you the complexes. So complex 1, 2, 3, 4. So complex 1 is NAD8, NAD to DH. So NADH dehydrogenase. DH is dehydrogenase. Okay. So these are the complexes, and I suggest you memorize them because it will help you a lot in solving the questions. And what other major enzymes is ATP synthase, which produces ATP by chemiosmosis because of the proton gradient. And hydrogen, we basically just move hydrogen around through the membrane of the mitochondria in the outer and the inner mitochondrial spaces. And oxygen, I need you to know that it is the final electron acceptor. Just knowing that can help you a lot in solving. So take your time answering. It needs a lot of concentration because there is a lot of drugs and a lot of regulation in this. Okay. Okay, Do we have any answers? C, that is correct. Do you know why? Can someone tell me why is it DMP? Why not antimycin, for example? Why not azides? Okay. Let's go with this. So you did an experiment and you found when there is a normal everything. Pyruvate is normal and malate and succinate, when you add all of these ingredients, basically, the ATP production is normal. Sorry, the TCA is normal, okay? But then you find that ATP synthesis is impaired. That means that there's something that you added that will inhibit ATP synthesis. What produces ATP? ATP synthase. Which of the following will inhibit ATP synthase? It's this uncoupler dinitrophenol. Okay? Antimycin, just as a review, antimycin A will inhibit cytochrome C. And rotenone will inhibit complex 4. Okay? And DNP is our answer. It will inhibit ATP synthesis by, which is like the chemiosmosis process. And oligomycin will also inhibit ATP synthesis. Okay? Clear? Need a thumbs up or someone. Is it clear, everyone? I can explain it one more time if that. Okay, thank you. Okay, which of the following statements best characterizes ATP synthase? So, C, yes, that is correct. That is correct. It is literally the definition of what ATP synthase is. It's I don't know what the structure is, but it's like a helicopter thing that the proton is pumped through down the proton gradient, and this process is chemiosmosis, and meanwhile it produces ATP. And this entire complex is the ATP synthase complex. Good job. Okay, now this question. Okay. E, okay, sorry, I didn't see your answer. It is correct. The answer is E. Okay, forget all of this. You don't have this. You don't need to know this. The answer lies here. Which defect? The defect is in complex 2, and complex 2 is succinate. Good job. Okay, the next question. Inhibitor, cyanide. Do we have someone? Oh my God, sorry. But you saw the question. You saw the answer. Okay, let's discuss it. Okay, one of the clinicals in the ETC or in the ETC lecture is cyanide poisoning. And what I need you to know is that cyanide poisoning will inhibit complex 3 in ATC. Okay. Sorry about that. I will try to control the okay. So these are the clinicals in ATC. So analgesics, these are basically pain suppressors, like the paracetamol or Rivadol. They are like one of the analgesics that you have is coenzyme Q10. It's a supplement for muscle pain. Rotenone will inhibit complex 1, and cyanide poisoning and carbon monoxide poisoning will inhibit complex 4. Okay, and oligomycin will inhibit ATP synthesis. Uncouplers like DMP and aspirin, thermogenin, they are all uncouplers. And uncouplers basically, they will go through with the energy production, but no ATP. I mean, they will go through the ATC with no ATP. Okay, so they don't produce enough ATP. They only produce energy or like heat. Okay, and newborn, the brown adipose tissue. This is also important because they, the brown babies. No, sorry, not brown babies. The babies have brown adipose tissue. So sorry, the babies have brown adipose tissue because they need a lot of heat production. Okay. So they have this brown adipose tissue, which is basically also an uncoupler. Okay, So any questions about ATC? No questions? Clear. Okay. Is it complex 3 or 4? What's complex 3 or 4? Sorry. Okay, let's move on. Can you please elaborate? What's complex 3 or 4? What you're talking about? Okay. Let's move on gluconeogenesis. Cyanide poisoning. Oh, okay, it's a mistake, a typo. I'm going to fix it, but it is complex 3. Thank you for pointing that out, and sorry again. Okay, let's move on in gluconeogenesis. New meaning using lipids and proteins to make us glucose. And okay, lipids, triglycerides. We have fatty acids and glycerol. Which one do we use? Is it the glycerol or the fatty acid? Or both? Okay, no one's answering. Okay, so we can use both, but we prefer using glycerol. Okay, so we don't use fatty acid that much. You're going to discover that in MOL 2, but let's leave that in MOL 2. Okay, but we basically use glycerol more than the fatty acids. But we just say that gluconeogenesis is a process of using or utilizing the lipids and the proteins to make us the glucose in the fasting states when the glycogen is the source of the glycogen is over. Okay, so let's go with the first question. Acetyl-CoA enhances the rate of gluconeogenesis by acting as an obligate activator of what? Of the following enzymes. Okay. Yes, correct. It's a simple recall question. It's a good job, guys. It's acetyl-CoA. It's an obligate activator of pyruvate carboxylase. Okay. The purpose of Cori cycle is to shift the metabolic burden to which of the following direction? Cori cycle. What is the Cori cycle? Okay. E. Yes, correct. Muscle to liver. Cori cycle is basically a crosstalk between the liver and the muscles. The muscle will give you the lactate. It will give the liver the lactate, and the liver will utilize this lactate to give the muscle a glucose again. So this is the Cori cycle, okay? Which is a good thing because after exercising, when you produce a lot of lactate and you want to get rid of it, the liver, as we know, it's a detoxifying organ. It does a lot of things. It will take this acid and make glucose out of it, okay? Lactate. Good job, guys. Okay, during early fasting, glycogen is used as a source of glucose for the blood. After liver glycogen is depleted, which of the following occurs? Glycogen is depleted. This is a keyword. Okay. Do we have an answer? C. No, please try again, but good try. Fatty acid adipose converted into glucose in the liver. Okay, so you got the concept. It is not C. But you got the concept. The answer is A. The amino acid of the muscle proteins are used to synthesize glucose in the liver. Okay, you finished the glycogen source. What you're going to do is you're going to undergo gluconeogenesis by using the fats and the amino acids. Okay, I get why you got the confusion. Why didn't we use the fatty acids from the adipose tissues? Because of two reasons. Number one, we prefer using glycogen first, then fatty acids, because breaking down fatty acids is a very long process and it requires a lot of enzymes, and it's regulated after, I think, 72 hours of fasting. Okay. The second thing is amino acids are very easily deaminated by enzymes, and it will be converted into the citric acid cycle intermediates. For example, as you know, pyruvate can be converted in alanine can be converted into pyruvate, and what is the other enzyme? aspartate can be converted into oxaloacetate. Okay, so amino acids are easily manipulatable, I think, to enter into the TCA. And another reason is, think about it this way: when you stop exercising for a long time, you start losing muscle before you start gaining fat. Did you get the idea? So if you didn't exercise, you lose muscles because amino acids are degraded quickly. And when you don't eat for a long period of time, like starvation, you will lose muscles before you start utilizing the fat and you lose it. Okay, so keep this in mind. Amino acids will be used before the fatty acids, and we prefer glycerol more than fatty acids because it's easily converted into glyceraldehyde 3-phosphate, which is an intermediate in glycolysis. Is that clear? Clear, everyone? Clear. Good job. Okay, now the maximum capacity of the liver to carry out gluconeogenesis during starvation depends on which of the following reasons. Okay, take your time answering it. Okay. C. Yes, that is correct. Good job. Okay, let me go. Why is it C? So they said after periods of starvation, think about it directly: hormones and livers and everything. Gluconeogenesis is hormone regulation. Okay, gluconeogenesis. When you are doing gluconeogenesis, you need hormones to stimulate this process, and this process was only stimulated when you don't have glucose or glycogen stores. Yeah, yes. So what will happen is that your pancreas will release the glucagon, and glucagon will stimulate gluconeogenesis. Okay, what glucagon does is it acts on the cell, it goes and binds to its receptor, and it stimulates gene expression. And if you remember in the lecture, the gene expression will go into the PepCK gene, okay, pyruvate phosphoryl PepCK, and it will stimulate the production of this enzyme. And yes, that's it. And PepCK is important because it will make us pyruvate, which will go into oxaloacetate, and we can do the gluconeogenesis. Okay? Did you get it? So just think about it: prolonged fasting, you will start releasing glucagon, and one of the effects of the many effects of glucagon is gene expression on the PepCK, and you have a lot of PepCK, and then you can do gluconeogenesis. Did you get it, guys? Okay, good. Thank you. Let's move on. Okay. Which of the following compounds would be utilized by a person on carbohydrate-free diet as a source of carbon atoms for de novo glucose synthesis? Carbohydrate diet, keto, the keto diet, right? Yeah. Okay. Okay. C. Yeah, it is C. Okay. Very quick question. Did you guys take any of these, even if you know what are these? Did you take it? Did you take hydroxybutyrate? No. Hydroxybutyrate and acetoacetate, these are ketone bodies. This is a MOL 2. Ignore it. Cholesterol, that's MOL 2. You didn't take it. Palmitate, again, it's MOL 2. So again, free carbohydrate diets, as we said, you don't have glucose, you don't have glycogen. What you're going to do is utilizing the fat and the protein. Okay, the options doesn't have any of the amino acids, so we didn't choose that. And let me ask you, sorry, if I have fatty acids in the choices, which option will you choose? If I have fatty acids in the options, I will still choose glycerol because we utilize glycerol first and then choose the fatty acids, or then go and use the fatty acids. Okay? Someone said no. What do you mean by no? Okay, can we move on? Okay, can we move on? Oh, sorry. Okay, you didn't take them. Okay, thank you. I thought that I said something that you didn't understand or something. Okay, but thank you. Anyways, let's move on, guys. We are done from what was this? Gluconeogenesis. Let's go into glycogen metabolism. Glycogen metabolism. This is like the glycogen, big glycogen atom, and this is the glucose, and you are going back and forth. If you are breaking glycogen, this is what? This is glycogenolysis. And if you are making glycogen, this is glycogenesis. Good? So this lecture is both of them. So I need you to concentrate because there are a lot of enzymes and a lot of regulations, but it is, a relatively simpler topic, inshallah. Yeah. Okay, this is a summary slide again. What is the difference between them? This is glycogenesis, and this is glycogenolysis. Good? Okay, let's start with the questions. Take your time reading it and go ahead. Okay. Do we have any answers? C, C, A. It is C. Yes, correct. C, yeah. Why is it not A? Glycogen phosphorylase. Because the problem here. Okay, I will tell you. There are a lot of keywords in this question. First of all, he said he has myopathy and muscle muscle weakness, and he has heart and liver problems. I told you guys after every lecture there will be like a summary slide for all of the clinicals, and this representation or this clinical vignette is talking about glycogen storage disease type 2, which is Pompe's disease. Okay, and Pompe's disease is without any of the complications. I just need you to know that Pompe's disease is there is a deficiency or there is a problem with the liver alpha glucosides. Okay, so it's not A and it's not D and it's not E, because they said when you take a liver biopsy, the glycogen structure itself is not faulty. It's not it's normal glycogen. Okay, so there is no problem with the branching and the branching enzymes. There are no deficiency there. Okay, again, this clinical vignette or this representation is one of the clinicals that you guys unfortunately need to know, which is type 2 glycogen storage diseases or glycogen storage disorders, and that's Pompe's disease. Okay, we will have a summary slide at the end, so don't worry, but just, did you get it? Yes, good job. Can we move on, guys? Okay, I just need a clear thumbs up so I can actually move on. Okay, thank you. Okay, an 18-year-old man visits the doctor due to exercise intolerance. His muscles become stiff, weak during exercise, and sometimes he has cramps. This is a keyword. Okay, at times his urine appears reddish-brown after exercise, and ischemic forearm exercise indicates very low lactate production. A potential enzyme defect in this man would be... Did someone answer? 1 second. What did you answer? You answered A. Okay, yeah, that is correct. Good job. Can you guess what type of disease is that? Because you do have it as well. What type of glycogen diseases? McCardle's type. Yeah, okay, good job. Okay, when glucose is incorporated into liver glycogen, which of the following is required as a direct glycosyl donor? Okay, it's E. Yes, correct, good job. Glycogen synthase is the enzyme responsible for turning or converting glucose into glycogen, and for that you need UTP. Good job. Okay, these are the clinicals as I promised. You have two types of glycogen storage diseases, and I made keywords to look for in the question when you are suspecting that this question is about this lecture, which is glycogen metabolism, and the question is regarding, diseases and enzyme deficiencies. So, this big enzyme deficiency is McArdle's disease, and the keywords here is muscle cramps and poor tolerance to exercise, as you had in this question. He has sometimes cramps, okay, during exercise. That is a keyword, okay? And type 2 glycogen storage diseases, as Pompey's disease, there is a normal glycogen structure, debranching and branching enzyme, okay? And you have the person had cardiomyopathy and muscle weakness, which is in our first, wait, where is it? Yep, it's here. He has myopathies, enlarged liver, heart, and heart failures. Okay, so look for keywords. Clinical specifically, if you get a disease, look for the symptoms or the main symptoms for this disease, and you will know what the question will want from you. Okay, did you get it, guys? Again, I just need a thumbs up so we can move on. Okay, thank you. So the last lecture in carbohydrate metabolism, that was a very big lecture like series, is the alternative carbohydrates. So as we know, we talked about glucose and how do we convert it into glycogen and how we can use the fats and proteins to make glucose and a lot of things. But we also have, other, monosaccharides like fructose and sucrose. And we have this as a pathway as well. So let's start with the questions. Okay, we have the fructose pathway and the galactose pathway, and I hope you guys studied that. If not, we have also a summary slide at the end. Which of the following represents the enzyme's deficiency that leads to essential fructosuria? C, a lot of C's. Good job, guys. It is fructokinase. Basic, simple, recall, and good job. Okay, very big summary or like clinical vignette, and take your time answering it. But you don't have to read all of this, and just focus at the end of these lines. Okay, but take your time nonetheless. Someone answered and they said B. Yes, good job. Good job. Okay. How did you know it's B? And can you tell me the reason? I want you to tell me because you were the first one who answered. Hypoglycemia. Okay. Okay. And what do you think this guy have as a disease? Yeah.
Fructose intolerance.
Yes. Good job. Good job. Okay, this is the pathway as I promised. So this is fructose, and this is basically just the pathway. And this was our question. It talked about this. It had fructose intolerance. It cannot tolerate fructose, and this is the enzyme that we have as a deficiency here. Okay, next question. This is now we finish from the fructose, and then we have galactose. It's relatively simple and short questions because there are not a lot of questions in your breakdown about it. Okay, let's see. A female with classic glycemia who is on a galactose-free diet delivers a full-term infant. She is able to produce lactose in her breast milk because okay, did someone answer? C. Okay. No, it's not C. Try again. It's B. Yes, correct. Okay. Galactose and glucose, they are isomers, and specifically there is a type of isomers that we call epimers, and basically they are having the same structure but with a mirror side images. We call that epimers, okay? And we can convert galactose into glucose to make milk, okay? This is the pathway as promised. So you have galactose and you have this pathway, and at the end you have glucose, okay? And it's not C because it's hexokinase, okay? That's galactokinase, okay? All clear? Any thumbs up? Someone? Okay, great. Okay, now we have the clinicals. That was my notes from last year, so please, if something that you didn't take, delete it. But when I compared the lectures from this year and last year, there is nothing that was big. There are no big difference when I found, I went to the clinical sections. Okay, so just know that hexokinase has low affinity to fructose. As you said, also hexokinase has a high affinity to glucose, and glucokinase has low affinity to glucose. As enzymes and affinity and whatnot. Okay, and aldose reductase deficiency. I want you to remember that aldolase B, and hyperglycemia and just no hyperglycemia is found everywhere. High fructose diets and essential fructosuria, which was our first question, and fructose intolerance, which was our next question. This is for fructose. Now this is for galactose. I want you to remember galactosemias and lactose intolerances, and the fact that you can convert galactose into glucose because these two are epimers or like isomers of each other. Okay, everything will be sent, so don't worry about that. We are focusing on solving questions, and explanations also is found in the notes section of the slides. Okay, now we have pentose phosphate pathway. Can we move on? I need a thumbs up. If you have any questions regarding any of the previous lectures, please send or ask or whatever. Okay. Let's move. Okay. This is just, again, a summary slide of this big pathway. Ignore this. This is the important part, okay? But I just added it for I was bored, so I added it here. But focus on this part, okay? And transketolase and andolases. Okay, and these are the clinicals for phosphate, the pentose phosphate pathways. Let's start with the questions. Okay. Sleep. I swear. Okay. Oh, you guys answered. I'm sorry, I didn't see that, but it is transketolase. Good job. Good job. This is the pathway, and he was deficient in this enzyme. So yeah. Again, I want something to highlight that transketolase requires thiamine. I want you guys to tell me what other enzymes will require thiamine or B1 vitamin. What are their enzymes? Two important enzymes. Okay, I'm gonna tell you anyways. So vitamin B1 or thiamine deficiency will have a problem in 3 enzymes because these 3 enzymes will require thiamine as a cofactor or a coenzyme. Okay, one is transketolase, as you can see in the question. Another one is ketoglutarate dehydrogenase in the TCA cycle, and the third one is PDH. Yes, good job. Pyruvate dehydrogenase. Between pyruvate, converting pyruvate into acetyl-CoA. Okay, so 3 enzymes that will require thiamine, and it is very important. Just memorize them, and it will be so much easier on you. So transketolase, ketoglutarate dehydrogenase, and pyruvate dehydrogenase. Okay, so when you see vitamin deficiency, specifically thiamine B1 deficiency, think about these 3 enzymes and a problem. If you have this clear in your mind, even before answering the question, you will know what the question will talk about or what the question will want from you. Okay, let's move on with the other question. Which of the following is an obligatory intermediate in converting ribose biphosphate into glucose 6-phosphate? Again, it's just recalling the process or like the pathway. A, no, it's not A. Someone said E as well, no. Okay. D. Yes, yes, it is D. Okay, again, it's just remembering the pathway. Look here, ribose 5-phosphate, and xylose are important in this pathway to make glucose at the end. Okay, I told you don't remember these are not important, but this is important, and xylose is one of them. Okay, okay, good job. Yeah, I had it here. I didn't have to go back, but this is the important part of it. Okay, now this is the last question, I think, in the pentose phosphate pathway. Is that your answers, guys, or like that was from the previous question? A, no, please try again. Okay, D, someone said D. Yes, that is correct. Okay, what is the keyword here in this question? It's primaquine. Okay, this is it's an antipyretic, or like it's basically a drug, and it's taken for G6PD deficiency. Okay, I told you there is a clinical section here, and look, G6PD deficiency, you give them primaquine. Okay, that is a keyword in this question. Okay, so the doctors and the lectures, they give you the clinicals not just for for your interest, but it is important. I know it's another load to just memorize drugs and clinicals and whatnot, but they do help you in the questions, especially because these questions are clinically based. Okay, so this is the keyword in this question. Okay, now a tables question. I had to add that, even though I hate tables and questions related to tables, but yeah. Okay. Okay, this question integrates a lot of concepts, especially DNA synthesis. So think about this lecture as well. Okay. Do we have answers? No, it's not A. It's not B. It's not A or B. Think about it. C, D, no. Okay. Okay, that's the answer that is left. Obviously, it is E. Okay, let's take our time and let's explain this question one by one. Okay, so first thing they told you that is the cell, it's in the S phase. Think about S phase synthesis of what? Synthesis of DNA. And you want DNA, what do you want when you are making DNA? You want nucleotide bases. And the nucleotide base is made of which sugar? It's ribose, which happens to be also in our pathway of pentose phosphate pathway. It's here, ribose. Okay, now the transketolase, let's go back to the question 1 second. Okay, the transketolase enzyme, it should be active because it makes ribose, it literally makes it. So we need this enzyme to be active. That rules out what? That rules out B, and that rules out D, okay, because we want this to be active. The second thing is we need PFK1. Why? Why do we need PFK1? PFK1 is for what? For glycolysis. We need energy. Synthesizing DNA requires energy, and that's why it will be active. And that rules out option B, okay, and option C. And we are left with this A and E. Okay, will glucose 6-phosphate dehydrogenase be active or inactive? How is that? It will be inactive because you are making a lot of NADPHs. Okay, let's go back to the pathway here, guys. 1 second. a lot of NADPH. And it is an end product feedback inhibition on this enzyme, which is glucose-6-phosphate dehydrogenase. Again, I told you focus on the regulatory steps, especially the regulatory steps, 100 times the regulatory steps, because one keyword in the question or one small things in the question will change everything. Okay, so NADPH, when you are making more of this, it will inhibit this enzyme, which is a regulatory step in the process of pentose phosphate pathway. Okay, and this is a clinical here, which is it will stick the entire time with you. And a deficiency in this enzyme, glucose-6-phosphate dehydrogenase, will lead to hemolytic anemia, and it will also be found in this clinical section in the, in the presentation. So did you get why the answer is E? If anyone is not sure about something, I will repeat again. Okay. So just a summary, the guy, or like this cell, this cell is in the S phase, and it wants, nucleotide bases and nucleotide, the structure of it, as you learned in the DNA synthesis lecture. It's a ribose sugar, okay? So it needs ribose, and ribose will be active, okay? You need a lot of glucose because you need ATP for DNA synthesis, and that's why PFK1, which regulates the steps in glycolysis, is active. And the second thing, you are making the pentose phosphate pathway is very active here because you want a lot of ribose, and consequently, you are making a lot of NADPH, and NADPH is an innate inhibitor of glucose-6-phosphate dehydrogenase. Okay? I hope everything is clear, and if not, take your time to process it. I know it's a very complex question. It integrated 3 lectures in one, but I hope that you guys understood it. We move on? Okay, let's move on. Okay, we are done, and now this is the ROS. Personally, it's my favorite lecture in the entire of MOL. I don't know why, but I just like it. And let's move on. Okay, I need you guys to remember this and keep this at the back of your mind. This is the enzymes and the substrates that requires it. This is hydrogen peroxide, which will be converted to water when you have catalase. This we know about. This happens in the lysosome. But we also have the glutathione peroxidase, which will oxidize the reduced glutathione in this, and this will also convert the peroxide into water. Okay. And in the process, you are making NADPH with the glutathione reductase. Okay, so this, keep it at the back of your mind. Another pathway or reaction to keep at the back of your mind. Okay, let's start. Okay, so this guy has chronic granulomatous disease, CGD, which is also clinical in your list. Which of the following enzymes will cause the phagocytic cell dysfunction? A, yes, good job. Good job. Why is it A? I told you one thing, small little thing, that will change the entire of the questions. Okay, so he's making a lot of peroxide, and let's go here. He wants to make a lot of peroxide. What is he making in the process? He's making a lot of NADPHs. Okay, a lot of NADPHs. Okay, what will this inhibit? Glucose-6-phosphate dehydrogenase. Good job. Okay. Next question. Did someone? Oh, I'm so sorry, guys. I think my internet lagged. But yes, the answer is hydrogen peroxide. I didn't see your answers, so. But yeah, you are good to go. This is the, a screenshot from Dr. Ahmed's slides. Memorize this if my drawings didn't or confused you. But this is basically what you need to know. Okay. I think it's the last question in ROS. Maybe. Oh, it is the last question. It's before the last question, sorry. But take your time answering it. C, yes. The answer is C. Good job. Okay, so the red blood cell is weak in a lot of ways. Firstly, it doesn't have mitochondria. Second thing, the membrane is very weak. So any oxidative stress that will be upon this red blood cell, it will damage it. So we want something to protect it. Okay, so this guy has anemia, and this anemia is because of membrane oxidation. The red blood cell is under very free radicals and oxidative stress. Does someone want to say something? Please go ahead. Hello? Okay, let's move on. Okay. B, no, it's not B, it's a C, yes. Whoever said C, you are absolutely correct. Reduced glutathione. Okay, again, it goes back to this. Okay, which one is reduced? This is the reduced part, okay? So it is reduced glutathione, sorry. Okay, now this is the clinicals that you guys need to know. Again, chronic granulomatous disease. If you know this, you know what the question is talking about, as there is a question that I added about it. And yes, that is it about reactive oxygen species. If you have any confusions, please let me know, because it's a relatively difficult concept to grasp, but it's just basically making a lot of free radicals to have an oxidative stress on the cell. And this is good when you want to tackle bacteria. It's bad when it's against you, as the case with, hemolytic anemia and CGD. Okay? Clear? Okay. Now we have our last two final lectures, which is alcohols and vitamins, and you guys are free to go, good to go, and inshallah you will finish MOL ala khair ya Rabb. And let's do that. Don't get scared with a lot of text. Just focus on what the question wants, and it will be there, like here somewhere. Okay? Take your time. Oh wow, mashallah, you answered very quickly. Good job. Okay. So the keyword here is with nothing to eat. That means that he is doing gluconeogenesis. And he is also a chronic alcoholic. That means that there's very high NADH, NAD plus ratio, because this is basically just the pathway. If you know the pathway, you will know what he wants. Good job, guys. And what does he have? Do you think, is he, a clinical concept? It's he's having lactic acidosis. Okay? Is that clear? Think about alcoholics will always have lactic acidosis. And you guys are taking Greenland, so you should be much more informed about this than I am. But yes, good job. Okay, this question. You just mentioned it. It is lactic acidosis. Chronic consumption of alcoholism will lead you to have the condition called lactic acidosis. Not metabolic alkalosis or acidosis, it's lactic acidosis, okay? Which of the following chronic effects of alcohol consumption is irreversible? B1 deficiency. E. Yes. Liver cirrhosis, unfortunately, it's a horrible disease, and it's an irreversible disease of the liver trying to, get back to what's normal, but you are giving it, alcohol and damaging it more. Someone said B1 deficiency. Can you please elaborate? B1 deficiency in what exactly?
No. So basically, the reason for lactic acidosis due to him being alcoholic is because of B1 deficiency.
Okay. And it's also because of the increased NADH NAD plus ratio. You know why? Because this will, lead you to the anaerobic glycolysis pathway, which you are making a lot of lactate. You are absolutely correct. Okay. Okay, this is again a summary slide for the pathway. And these red or like inhibitory things, these are drugs. Please ignore them. This is from first aid. This is when you are inshallah taking daysonally if you're planning to. So ignore these drugs. You don't have them. Focus on this line. Okay. And this is the, who said thiamine deficiency or B1? Yes, you are absolutely correct. Okay, this is a clinical slide for the alcohols and alcohol metabolism, and now we are taking the vitamins. Oh, we are done. This is just a random meme that my brother told me about. I thought that I should add it, but yeah, let's continue. Again, summary slides before the questions. I'm going to skip for shortage of time, but it will be included in the presentation. So this is everything you need to know about vitamin A, vitamin D, K, E's, and the B's. Okay, so let's start. Okay. Someone said E. It's not E. It's oh. Okay. Yes, it is vitamin. Yeah. Good job. Good job. Because he said prolonged clotting time and vitamin K is very important in the clotting and the coagulation cascade, as you guys took in the F&D block. Okay. Oh. Okay. Is it D? Yes. Yes. Good job. It's riboflavin, which is vitamin B2. And the keyword here is red fissures in the corners, and it's this is the keyword here. Okay, so if you have glossitis or if you have any inflammation in the lips, on the nails, oily skin, this is the riboflavin, which is vitamin B2. Good job. Okay. Okay. Someone answer. If you said D, no, this is the wrong answer. Okay, it's A. Yes, good job. Good job. Okay, let's take this step by step. That's a lot of vitamins, so we need to cross out whatever is not, correct. So the question said it's 24-hour fast. Always think about glycogenolysis and gluconeogenesis. You don't have glucose, okay? And after 24 hours, you finish the glycogen stores, so you are only doing gluconeogenesis. Okay, this is number one. So the factors and the coenzymes that are required for gluconeogenesis are what? Rule out the choices. Okay, you need vitamin B6 for that. Okay, and vitamin K, D12 in gluconeogenesis, you don't need that, so you cross out B and C. Okay, you don't need vitamin D's, or you also don't need K, so you cross out B and C, so you are left with A and D. Okay, so is it vitamin B6 or vitamin B12 that you need in gluconeogenesis? It's vitamin B6. Okay, and you guys are going to take it later. I don't know if the doctor mentioned it in your lecture, but B6 is important for transaminases enzyme, and transaminases, amine means amino acid, and this is important for converting the amino acids into the the glycolytic intermediates like oxaloacetate, pyruvate, etc. Okay, so that's why it's A. Is everything clear? Clear. Good. Okay, the activity of aspartate aminotransferase require the following vitamins, such as which enzyme? I just mentioned it. We just discussed that. Do we have answers? Okay. D. Yes, that is correct. It is Z. I told you guys this question, last question, he said we were talking about gluconeogenesis, and gluconeogenesis requires amino acids to convert it into pyruvate or oxaloacetate or whatnot. Okay, and this requires vitamin B6. Okay, so keep this in mind. Which group of enzymes? Transferases and transaminases and anything that is amine and then an ase. Okay, so it's a B6. Okay. Okay, solve this question. It's very, very clear here. Okay. Vitamin E. Sorry, it's C, yes. Okay, whoever wrote this delta, you are creative, but it is C, clotting factor synthesis, because warfarin is it's an anticoagulant. And think about anticoagulant vitamins, it's K, okay? Whatever in the, you know, clotting cascade or the coagulation cascade, we need a vitamin K, okay? What is vitamin K is warfarin's antagonist, okay? So, yeah, if the patient is on warfarin, which is an anticoagulant, you don't give something which will increase his bleeding. Yes, which is vitamin K. Okay. Okay. The last question, I hope, or is there another question? I think there are like 3 more left. Okay, let's solve it.
E.
Yes, yes. Okay, tell me why. Please stay with me and tell me why it's E.
Because if I remember correctly, B1 like
Yes.
thymine, yeah, transketolase is
Yep. For B1 deficiency. Okay, do you know what other enzymes? I told you guys about it. 2 more enzymes that require B1 deficiency. Is it required? Yeah.
PDH.
Yes, and?
Oh, the last one I forgot.
Alpha ketoglutarate.
Not isoglutarate. It's yeah. It's alpha ketoglutarate. You said isoketoglutarate, but it is ketoglutarate dehydrogenase. And you guys are absolutely correct. Good job. Proud of you all. Okay. So just to recap again for for the recording's sake, B1 deficiency or thiamine deficiency will give you problems in 3 enzymes. In this question, it's transketolase, then pyruvate dehydrogenase, and ketoglutarate dehydrogenase. Okay, good job. Okay, now for the next question. Let's. Oh, okay. This is a typo on my part. I apologize. Okay. Someone said C, C, C. Yes, very, very. It's scurvy. Scurvy is vitamin C. We know that, you know. Okay, good job. Okay, now we are done. Alhamdulillah. These are the tips before you guys leave. Thank you so much for joining, and inshallah, the exam will be easy on you. Uh, yeah, just a side tip after after you finish everything, please sleep well before the exam. And I told you to think about the question, read the question, think about the regulations, the enzymes, anything that gives you a clue about which pathway they are requiring, and you will know the question will want from you, inshallah. And another tip is, blurt the pathways before you start the exam, before you type the, after you type the password, of course, and enter the exam. Before you read the first question, type or write down all the pathways that you know, because it will help you so much. I did this in MOL 1 and MOL 2. I just look at the pathways, know what the question will want, and I know which deficiency the enzyme requiring, or know which disease. Okay? So please blurt out the pathway. It will help you a lot. Yes, it will take a little bit time, like 5 minutes, 10 minutes if you're writing fast, but it will save you so much. Thank you guys so much for joining. Please scan the code. It was very, very, requested that we scan codes in this PAS session. So please scan this code. And thank you so much for joining. If you have any questions, I'm more than happy to help you. And sorry for any disturbances or any, misconceptions that you guys had. Just focus on the lectures, and yeah, that's it. Best of luck, and thank you so much.
Thank you so much.
Thank you. Have a good day and good luck.